Now we're going to look at some of the harder questions, like into merit and excellence, and as part of that we're going to consider the concept of Z values. Now in fact you don't need the terminology, although the textbooks and everything will have it. What you need to do is try and follow the concepts. So one standard deviation either side of the mean includes about 68% of the values for all normal distributions. If we take an actual one, in this case I'm going to give it a mean of 24 and a standard deviation of 3, then plus or minus one standard deviation from the mean is from 21 to 27. But I can also write that in terms of the mean and how many standard deviations it is. So 15 is 3 standard deviations below the mean. And those numbers there in front of the sigmas are in fact our Z values. They are how many standard deviations the value is below the mean or above the mean. And this is the formula we use. It's given to you in the exam, so you don't need to remember it. The Z value is the distance from the mean expressed as a number of standard deviations. We take the value we're interested in, subtract the mean, and divide by the standard deviation. So in this example here, we have a mean of 37, standard deviation of 4. The value 30 is 30 minus 37 minus 7 below the mean, divided by 4 is minus 1.75. Now what we have to try and understand is that minus 1.75 means it is 1.75 standard deviations from the mean. The negative doesn't mean anything other than below. It's the 1.75 standard deviations that's important. When we take a standard normal curve, then it has a mean of 0 and a standard deviation of 1, and our formula simplifies considerably. Minus 0 for the mean divided by 1, they both cancel out, and the Z value is the value of interest for the standard normal curve. And we can use that with the calculators to find answers to some of the harder questions. Here's one, for example, a very hard one. The middle 90% of values fall between 45 and 50 for a normally distributed sample, and we are asked to calculate the standard deviation. Whenever we get ones like this, first thing to do before we go any further is give a sketch so that you understand what's going on, and this basically explains it. And we want the middle 90% of values to fall between 45 and 50. First up, we use our knowledge of symmetry to say that the mean must be halfway between those two values, because the standard normal curve is symmetric and the mean is halfway between 45 and 50. Now we need to work out how many standard deviations that is. So we turn our calculators on, stats, distribution, the normal curve, and then the inverse normal curve. Now we're talking about the middle 90%, so we are at the center, and it's an area of 0.9. The sigma for the standard normal curve is 1. The mean is 0. So when we execute, we see that, just look at it again, the 90% area in the center is between minus 1.644 standard deviations to plus 1.644 standard deviation. So there we have it. The area of 0.9 is associated with a Z value of 1.645. So what that means is from the mean to the mark, if we want it to be 90%, it has to be plus or minus 1.645 standard deviations, and we know from the context of our question that that is 2.5. Solving that, we take that, rearrange it, and we get our sigma. Sigma is 1.52. So the standard deviation for this sample is 1.52. Try again. the company wants 1% of its widgets to be less than 300 millimeters long. The widget maker is known to a standard deviation of 3.6, so we need to set the machine so that only 1% is below. And this is the situation. We have 1% is below 300, but we need to find the mean. The area of 0.1 is a z value of 2.326, so we'll just check that out. We want the lowest 0.1, so our tail is left, our area is 0.1, and standard deviation is 1, and mean is 0, because this is a standard normal curve, and there it is, 2.326 standard deviations from the mean. That's where that number comes from. It's this area, the tail left, an inverse normal on the standard normal curve. So we have that our mean is sufficiently above 300 to be 2.326 standard deviations. Well, we're told what the standard deviation is, 3.6. So that distance needs to be 8.3736 millimeters in order to have the highest 99% above it. And we can add that onto our 300, and there it is. There's the answer. 300 plus 8.3736, and we'll round it up in context. The machine needs to be set at 309 millimeters. So this is what you need to remember. If you need to calculate how many standard deviations from the mean, then inverse normal with the calculator set for sigma equals 1 and mean equals 0. You can use the formula sheet, but it's much slower. And then at the end you check your answer to make sure it's right.